of some water body is free to the air and the lowermost boundary will be fixed. So this type of channel is called as the open channel, and in this open channel the flows of the topmost portion are always getting disturbed by the surface and by the air. So and the bottommost point is fixed, as well as if we want to see the bottommost point, the surface is not smooth enough and it is rough, therefore it is making some local disturbances. So when all these things are coming into picture, if we want to see the velocity distribution of this type of flow, then it will get some parabolic nature. But in practice, some other types of velocity profiles are also possible. Okay, I am very sorry if some of the people will not see the things interested, because maybe this kind of things are very much scientific. So, and for that some knowledge, basic knowledge is required. So, if you do not feel encouraged, then you can leave the place, and those who are interested, they can only sit there. I will be happy to see those people who are really interested. Okay. So in actual practice, if we see any river, like any river which is in the mountain area, so in the mountain area, so the river beds are something like, and it is having some bigger size of gravels, which are generally called as boulders or cobblers sometimes, and after that, some sand will also be there. Now, when the flow is taking place in this kind of rivers, there will be some changes in the flow characteristics, means there will be some changes in the basic flow properties, like the velocity, like the shear stress. So these things will get changed. And if we want to get the idea about this, we are having many different approaches, many different techniques. So these things are very much interesting to the people, those who are working in the fishery sciences or in the pisciculture. So people generally want to see how in these places fishing can be done. So here you will see that some larger caverns are there, and in between sands are also there. So there will be some places where the velocity of water will be very low. And in these positions, the fishes will try to go there and take rest, and the fish hunter, he or she will get enough time to catch the fishes from those places. And this technology can be used even in any places to make the pisciculture. So things are very much interesting to see for the common people. But at the same time, those who are working as a mathematician or as an engineer, for them it is having some other interesting topics. Like here actually the flow is very much getting disturbed by the local darkness. Local darkness means in the bed, if you will see that sometimes somewhere some sand is there, some gravel is there. So if you have gone through the fluid mechanics, then in the very first chapter of the fluid mechanics, you have seen that viscosity is there and velocity profile is also there. So I'm not sure if you are going through Bansal pool or joining or large pools like this, but this velocity profile and the viscosity, these things are very basic, and probably you will see this in almost all the books of fluid mechanics. So there, if you will find that the velocity profile is drawn for a particular place, then for this type of cases, the bottommost point is very much important, because in the bottommost point, we are considering that there is no velocity of the fluid, and from there, if we are plotting one velocity profile, then it will take some parabolic shapes. Now, when we are not able to fix the place where will be the bottommost point, like somewhere here sand is there, somewhere gravel is there, so the bottommost point itself is very much irregular. very much heterogeneous. So bottommost points may be somewhere, that is for some places it will be up, and for some places it will be some down. So here it is not very much possible to get the velocity profile. Or if we get the velocity profile, then there will be some problems in getting the idea about the stress. Or if you want to get the other parameters like kinetic energy. So these things are also not so easy. So to solve this kind of problems, we will have to understand the base level first, and then we can solve the problem more easily. Now, if we see the velocity profile in open channel, so it is having some shapes, and this the whole, that is the bed of the remote is having some different layers. So the layers between two gravels are called as subsurface layer, and those who are working for the groundwater engineering, they are working in this field. And above this, the layer is called as interfacial sublayer and forming sublayer, where the effect of bed roughness is there, and also the effect of the viscosity of water is also taking place. And above this, the velocity profile follows the logarithmic law, and so it is called as the logarithmic layer. And above this, the outer layer takes place, where the flow is generally controlled by the turbulence, and this is fully turbulent zone. And we people are mainly working with this zone only, the outer layer and the lower layer. So when we want to do some experiment, so it is not possible to get the actual figure, the actual thing, what is happening in the river. So we are making some artificial arrangement of channel, that is similar kind of rivers are made in the laboratory. And here you can see that in the first figure we are seeing one channel is there, and for that you can understand that the bottom surface of the river is shown by the gravels, and somewhere it is the sand, which was in the first figure. And in the second figure we are generally showing one, that is receiver, which is giving the velocity component, that is actually for, that is fluid mechanics. You will see, if you want to go through the book, then for that the velocity profile in open channel, it is having actually three directions. And here are the basic differences between solid and fluid. For any solid material, you can say what is the velocity of the wave, what is the velocity by which the train is moving, what is the speed by which the plane is moving, but it is not possible to say what is the exact value of the velocity or by which the water is flowing. So, we are having some instrument. Using this, we can get the velocities at different points, at different, that is height. And if we want to plot them with respect to depth, we will get some curve, and from that graph we can predict the velocity. Please mind it, we are not saying that we are saying we are determining the velocity. We are just predicting it, because even after making several measurements, we will not be able to say what is the exact velocity. So the velocity that we are saying is just we are assuming the velocity. Now, for this kind of experiment, initially we use some non-dimensional number. That is, in your fluid mechanics book, you will see that non-dimensional numbers are there. Many kinds of non-dimensional numbers like Froud number, Reynolds number, Weber number. So many numbers are there. Mach number. So when we want to make some arrangement of the river in the laboratory, we fix the experimental parameters by fixing the Froud number between the laboratory and the field. And the Froude number is generally depending, Froude number is equal to V by square root GH. That means if we know the velocity in a river, the approximate velocity, and if we know how much is the depth in the river, then from there we can get the value, that is idea about the Froude number, and we can use the same Froude number in the laboratory by changing the value of the depth as well as by changing the velocity, because we will not be able to change the value of G. So considering that the value of G will be same for both the places, and we are making the change arrangement in such way. Now, depending on this, we are making the arrangement in the laboratory and we are fixing the parameters. Now, here is the details of that is instrument by which we capture the velocity reading. It is called as the vectino, and this vectino is having 4 probes which are able to give the velocity readings in 3 different directions, and with this we are getting the velocity, that is 100 readings of velocity in 3 directions in every second. So if we take velocity readings for a particular time, maybe for 5 minutes or 10 minutes at a particular point, from there we can get the average velocity. And when we are getting the average one, from there we are getting the fluctuation, and we are doing the remaining part of this. Now, here is another arrangement of the experimental setup. Like here also we have done some experiment with the sand and gravel, but in the downstream we are using some oil maker. Upstream. Oil maker means by which we can generate the oil artificially. Like if you will see, that is where the pisciculture is taking place, like in some places where the different kind of fish which need very high tides, to for them artificially we are creating waves. So here also we are having some wave making facility in the laboratory, and for this we are making some waves artificially, and we are performing some experiment. Again we are using some instrument to capture the velocity reading first, and after this we are doing some mathematical analysis. So I am not sure that if you will be able to understand the statistical or mathematical portion of this, but the things are something like this. Like if we want to plot the time versus velocity readings, then it looks like that. And from there we can get the average value at the fluctuation. And from the fluctuated part, we can do the mathematical analysis. So first one is the velocity power spectra. So according to Kolmogorov, we know that the velocity power spectra follows f to the power minus 5 by 3 slope in the inertial circle. So these things will be very much difficult for you to understand for most of the, that is because you are BTech students, so these things may not be so interesting to you. But this one is obviously you can understand. Like here we are taking the velocity readings at many different points. As I have told you that this is the case for the heterogeneous bed where the sand and gravel are there. So for this type of things we are making this kind of velocity profile. So you will find that this velocity profile is something different that you will see in the fluid mechanics book. That means that you have seen in the book is very much a basic one. But if you want to do some, that is parallel error or some research work, then you will find that this velocity profile itself is having many different shapes. Here, the first part of this, for that I am defining by one equation what is given in 1a, and the uppermost part it is following it is following 1/7 power law. So if you see the velocity profile, then 1/7 power law is very known law. and using that 1/7 power law you can get, that is, you can describe the velocity profile for any kind of flow, what is happening in the wave channel. So this is the Reynolds shear stress, and after this the things will be much irrelevant to you. So here is the Reynolds shear stress. So, like shear stress is there in the fluid mechanics, solid mechanics, shear stress is also, that is there also in the fluid mechanics. So, in fluid mechanics part also, if you want to get the idea about the shear stress, then you will find that when we are getting the bottommost point of the river, then for that the velocity is not having any value. So we are not getting any shear stress in the bed. Bed means actually the bottommost layer of the river, and if we make any artificial arrangement of the river in the channel, then the bottommost line of the channel is called the river bed. So here at the bed, as there is no velocity, we are getting the Reynolds shear stress 0. And when we are going above, so if we want to get go to the maximum level of the, that is loading, then again there will be no changes in the velocity. So for that we will get the values. So in between the values will be maximum in the bed level. Bed level means the top surface of the roughness. Like if it is gravel bed river, then the top surfaces of the gravel is called as the bed level. If there is a sand, then the topmost surface of the sand will be taken as the sand bed, and this is for the sand bed river. So depending on the bed darkness, we can say the river as sand bed river or gravel bed river, like this. So now from the, that is, if we see the topmost surface of the river bed, then for the bed, the value of the Reynolds shear stress will be maximum. Here Reynolds shear stress means actually, first of all, we are trying to get the velocity readings in 3 directions that I have already told. So in 3 directions means we will get the velocity in the direction in which the flow is going. And at the same time, there will be changes in the velocity in the vertical direction also, which is just in the perpendicular direction in which the flow is going. That means we will get some velocity readings in vertical direction, and that is streamwise direction, that means longitudinal direction. And from there, when we are multiplying the fluctuation of these two velocity components, then we can get the value of the shear stress, and this shear stress is called as the Reynolds shear stress. And this Reynolds shear stress, it becomes maximum if it is at the top level of the bed. And if it is at the top level of the water surface, then this value will be 0, because when we are going to the top surface of the water, then it is assumed that at the top surface of the water, the fluctuations will be very minimal, and there will be no effect of the viscosity which is seen in the, that is, lowermost point of the river. So I think you people are very much familiar with the, that is with the viscosity, aren't you? So I think you can remember what is viscosity. So it is generally taught in the school level nowadays. Earlier it was not there. So, but I see that nowadays that the students who are studying in class 8 or 9, they are also familiar with the viscosity. So the viscosity effect is mostly there in the bed level. That means if we go towards the bed of the river, we will feel the effect of the viscosity. But if we want to go, that is, we want to come above the level of the bed, that means if we want to go to the top surface of the water, then the effect of viscosity will get in place. That's why sometimes if we are trying to do something toward in the bed level, so sometimes you are feeling that the thing that you are trying to do, you are not able to do this. Like you are trying to move something towards the bed of the channel, you are not able to do this. Because there will be some opposite effect that you are feeling. And that is this, in these effects, one of the main reason is the viscosity. So we cannot see it, but we can feel. So these kind of things can be understood if we can use do some that is experiment, and after that, if we do some mathematical analysis of this, then we will be able to understand these things. Now, turbulent kinetic energy. So this is as simple as the kinetic energy that is generally seen. So kinetic energy, I think you people can also understand that there are two types of energies, like kinetic energy and potential energy. So when there is changes in the velocity, the kinetic energy will take place. And for water also, if that is as the velocity is defined at different levels, and also the velocity is changing with respect to time when the flow is there. So for that, the changes of kinetic energy will also take place. And if that kinetic energy we are calculating from the velocity fluctuations, that means the changes in the velocity, then we can say this one as the turbulent kinetic energy. So that turbulent kinetic energy effect will also be maximum in the bed level, because there the surface, that is bed roughness effect is there, as well as you will feel that viscosity effect is also maximum. So the turbulent kinetic energy effect will also be maximum. And those who are doing the physical, for them it is very much interesting to understand how this turbulent kinetic energy can be minimized. Because if some pieces will fit, that is, will be some more energy will be acting against the field, then that fish will not be able to sustain, or that will not be able to take rest there. So the physical, that is, people who are working with this, they are trying to minimize this turbulent kinetic energy. So in this way, these things are very much important for the engineers, those who are working with this, and also to the people who are working with pisciculture, and at the same time, the people who work for mathematics, they are getting some idea that here, when fluctuation is there, and when a large number of data is there, then mathematics will also work, statistics will also work. And nowadays, people who are working with machine learning, deep learning, they will also make some kind of prediction, because I have told that here, nothing is very much determined, but we are predicting everything. So, when prediction is there, this machine learning, deep learning, these are also coming into picture. So, this is a problem which is very much interdisciplinary. And when river is there, that means geology people will also work. So, in this way, that is here, you engineers can also join. And this is how I have got the job in ISI, because ISI is totally different place. That is a place for statistics people. But I have got some interest in this field. So you also will be, if you are interested, then you can also work in this field. Now, here the things will be very much in different way. So I want to conclude here. Now my suggestion is save water, save lives, because if you want to sustain, so it is very much important to take care of the rivers, because we are having shortage of rivers everywhere throughout the world, and this is that is difficult time. Here now the global warming is on high. So if you want to love people, then you have to love water and the water bodies and the rivers. So this is my suggestions to you. So thank you.
Thank you very much, sir, for such an interesting topic. Being civil engineer, we all know that how difficult it is to separate sediment from water and the complications involved in sediment flow. So this kind of experimental works are extremely difficult, and the analysis is also extremely difficult. You made it very simple, and we saw the graphs which were clearly showing the variations of the velocity profile. So thank you very much, sir. It was very nice. I hope the students will have so many questions because this is an experimental work, and we have so much of room to do more number of experiments. Students? Questions? Whoever wants to ask question.
Anyone with questions?
Sir, I have a small question, sir. Yes. Sir, have you, because sediment and sediment flow, you have tried these kind of experiments under seawater conditions? Because most of these experiments were sweet water or normal water conditions. So have you tried, sir? Because we know the density of water will have a lot of...
We have analyzed the waves. So when we are using the wave for these kind of problems, then we see that if there is no wave, there will be, that is, the flow condition will be something different from the wave current conditions. So for that, some more experiment is required, but nowadays it is very much difficult to get people interested in this field. So this is very much unfortunate, because this machine learning, deep learning will not do if you don't have the experimental data. So without doing the experiment, you will not be able to learn the machine, because if data is not there, what the machine will learn? Nowadays people are thinking in many different ways, but after a few years maybe people will again be shifted in this direction, because this is a basic need you will have to fulfill. Okay, so for you students also, I am having one suggestion. If somebody is having an interest to take part in this type of work for the summer project or winter project, so he or she can contact me and can go there. And for this kind of problem, it is having a very high demand in many different countries where there is a scarcity of water. But fortunately, we are not having that condition, but the things are not very far. You can understand the climate, how the climate is changing every year. So very shortly we will also feel the importance of the water resources engineering, and the things will get changed, and I think these young people can take part in this.
I have one question. I have seen that extensive study has been carried out with experimentation.
Yeah.
I have one small question, whether it is relevant or not, I don't know, as it is a water field. Nowadays, sediment in the river is a great problem.
Yes.
The reduction of fish in the river.
Yeah.
So, is there any solution with reference to this experimentation, what is presented?
The basic thing is, in the river we generally find many different situations. Like here, bed load, suspended load, this type of terms are there. So when the sand is, that is, there will be very much cover, or if we will not make any dredging day after day, then automatically this will be deposited year after year, and sometimes the river will get disappear. So the sediment is actually taking very important role, in the, that is, climate change and in the fishing. So every such kind of problem that is it is associated. The thing is that we don't have enough understanding of this, and we don't have that much of infrastructure. But to save the rivers, we do not have any other choice but to clean the rivers and to make the dredging after a certain period, and it is periodically you will have to do this. Otherwise, no science, no artificial intelligence can help you. Mathematics, nothing will help you. You will have to love the rivers, you will have to work for this. So, otherwise, nothing will help.
Thank you very much, sir, for such an interesting topic and providing an opportunity for students to take up internship at your institute. Thank you very much. It was very interesting. Now, I call upon Dr. Indranath Sarkar, sir, faculty and professor of Electronics and Communication Engineering Department, to felicitate Dr. Shankar Sarkar, sir, for such a wonderful presentation. Thank you very much. To conclude this session, we go to our final talk for today, that is our plenary session, which will be given by Dr. Virajesh Patnaik, sir, who is the director, Amity University. You've already heard his wonderful introduction about the student, teacher, faculty, and the subject interactions that we have in the morning. So I briefly introduce him. Dr. Patnaik, sir, he has done his mechanical engineering from Mysore University and MTech in mechanical engineering with honors from University of Engineering, Sambalpur University. He has obtained a PhD degree in the field of multivariate quality control in mechanical engineering from the prestigious institute, Indian Institute of Technology, Kharagpur. He has a total experience of 26 years of teaching and several research experiences. He serves as a director and professor and head of the department in various institutes across the country. Currently, he is working as a director at the Amity School of Engineering and Technology, Amity University, Kolkata. He has, to his credit, many publications, books, and international and national and international journal publications, and many more. I'll shorten up here and welcome him, sir, to deliver his talk to you.
মানে চিকেন তন্দুরি তো মানে মাস্ট লোকাল ওকে
চালাবে পছন্দের পকেটে ওই রকম কুপন থাকবে ডেলি 7 দিনের আর সপ্তাহে এরকম করে দেখাবে লাইব্রেরি অসব দেখে নিতে ছিঁড়ি খাবি আর কি দেখে যান বাচ্চা তো খাওয়া ঢাকেশ্বরীতে নাম দিয়ে মিড ডে মিল নাম হয়েছে ঢাকেশ্বরী কয়েকবার এই ফুল চিকেন তন্দুরি মাছ চিকেন তন্দুরি খেয়েছি চিকেন তন্দুরি টাচ লাগবে
আচ্ছা এটা এইচডিএমআইটা ডাইরেক্ট এইচডিএমআই পোর্টে ঢোকা হবে না? হ্যাঁ এটা এইচডিএমআই,
এটা কেবিলটা এটা কনভার্টার
না এখানে এইচডিএমআই পোর্ট আছে।
হ্যাঁ ওটা কনভার্টারটা না লাগলে হবে না
এটা তো ইউএসবি,
ক্যামেরা যাচ্ছে
সেটা বলছি না। এইচডিএমআইটা ইউএসবি কনভার্টারে ঢুকে ইউএসবিতে ঢুকে, এইচডিএমআইটা যদি ডাইরেক্ট এইচডিএমআইতে ঢুকে
তাহলে আজ কনভার্টার করবে
কেন কনভার্টার তো এইচডিএমআইকে ইউএসবিতে কনভার্ট,
হ্যাঁ
ডাইরেক্ট যদি আমি এইচডিএমআই পোর্টে ঢোকাই
এটা হচ্ছে যে ইউটিউব লাইভের জন্য
না না
হ্যাঁ
এইটা ওইখান থেকে এইখানে কানেকশন।
ওইটাই মেন ফাংশন আছে এই কালো মালটা
ওইটা শুধু
We'll start the session in 5 minutes. Kindly be seated.
ইউ আর অ্যাপিয়ার টু বি অফলাইন। বেশি তো আপডেট শেয়ার
মোবাইলটা দিয়ে করতে হবে বলে
কেন ওখানে নেট নেই?
না সব কোনো বিষয় নেই না ফ্যাকাল্টিগুলোতে কাজ করে ঠিক আছে এই ফ্যাকাল্টিগুলো আসতে করতে করতে এনবিএর কাজ করতে ওদেরকে কাজ দিয়ে কাজ দেয় আমি তো দেখি এই চুল এখন প্লেয়ার এই আমি বলবো নতুন স্টেডিয়াম নাম হয়ে গেছে এখন খাটে এটা নেই এই গায়ে হাওয়া লাগে आगे কান মনে হচ্ছে বন্ধ হয়ে শুনতে পাচ্ছি মনে হচ্ছে কানে খুব আটকে সে কমবে ঠান্ডা লেগেছে ঠান্ডা লেগেছে ঠান্ডা লাগাটা কমে গেছে স্টেশনে যাবে 10 টাকার একটা ইয়ে পাওয়া আদা শুধু এটা খাবো আদা আদা শুধুর প্যাকেট পাই 10 টাকা হ্যাঁ শুকনো আদা এটা কবে আমি ইএনপি দেখালাম দেখি ওষুধ খাচ্ছি তাই হচ্ছে জানালে হোমিওপ্যাথি ওষুধ আছে তোর এই রাস্টা আর বছর তোমাদেরকে খুঁজছে তো একদম বাকুদা রেগে গেছে ওইগুলো আমি দেখছি আমি ছবিটা আসো বসো অলরেডি দিয়েছে আমি একটা পিএইচডি ফ্যাকাল্টি চাকরি নেই দেবে না না চেষ্টা করে আমাদের দিচ্ছে না স্টুডেন্টরা কথা বলবে আমাদের শুনে আচ্ছা
good afternoon all. I could understand the vision of students sitting there raising a gap between two presentations. So anyway, I'll be discussing today the future of materials, the advancement in science and technology and a more sustainable future. So this, when you look at the recent two presentations, you must have found the hardcore of research and activity presentation there. But I'll discuss something which will be in general what exactly happening in this world related to smart materials and what exactly the industries and corporate sectors are doing for these smart materials, choosing these smart materials for a sustainable future.
6 অবধি সব ক্লিয়ার থাকলে তবে দেওয়া যায় মনে হচ্ছে দিতে পারবে না
So look at this. I'll divide the complete presentation of mine into two segments. First is that I'll be discussing about two sectors. One is an industry and other one is a corporate sector. Whereas I'll want to show you exactly what is happening there, keeping this in mind that the whole organization is thinking about to bring their organization more sustainable, their system sustainable, their technology sustainable. And in the second part, I'll discuss about more into the materials. Those are from mechanical engineering and civil engineering, whom we call it as smart materials, right? So let's look at this. What exactly company like, let's think about a chemical company. Any such company, what they are doing these days. So you know, may not be in third world countries, but if you look at the modern countries, the developed countries, what is happening? Now they are very much serious about the carbon they have with them. And the government has so well defined rules and regulations. You cannot run away from the rules and regulations, and for every industry they have to have, for every year they have to have and present before the government and the authority that what carbon they have with them. Maybe for any heavy structural industry, maybe even the IT industry. Every industry has to show in every year what exactly they are earning in these carbon pinch points. So what is the challenge with them? See, when any new things comes into the organization, it always makes it difficult for all the people working over there and the management itself. Like suppose, all of a sudden it will be told to you that none of you can travel to your organization with your own vehicle. Will it be okay for all of you? No, you know, it is not possible. Many of you will show your reluctancy that will not travel in a good car, a bus to the organization. So similarly, any organization, when they adopt the principle of having a sustainability in the organization for betterment of the future, so always there remains a challenge. So two things comes into that innovation may be once again changing the game in the chemical industries. This is one example I have taken for one industry, as chemical industry. The first point is innovation. We are into tradition, we have been developing, and innovation is in a space but very slow process. But if you think of a better industry, better product which will be sustainable and the future of the new generation will be good, then becomes easier innovation. And that innovation is not a research for years together, rather an immediate state, immediate action to bring up something very concrete so that you can develop such products. So the first thing comes in that innovation is most important, you have to do it within some years. Second comes a heightened focus on sustainability from the company's customer and policy makers. And for that, changing customer preferences. See, unless people like, if you look at, I'll show you in the examples in stages that when you use a badminton racket or lawn tennis racket, what is that material you are using just back? But what is the material you are using now? It's a substance called as propane. So these are the innovations which helps in creating a sustainable future like but it has some characters which is good for the nature. So there is a competition among the companies, there is a preference of the people. Unless you feel yourself as a customer that you require such products which will be good for the future, so there is no need of it. So the company's job is to make you people feel and realize a sustainable product is good in all sense. So there are the two challenges. The first, Some companies are pursuing research and development and invest in short timeless because it's a challenge for them set by announced sustainability targets from both private and public entities. That's the first one. The second comes there, these capital expenditure decisions in some cases must be made even before supply chain for new feedstock have been secured and project risk can be mitigated by long-term offline contracts. So it's just not easy to take a decision by the management to invest such a big amount to give some innovation for the betterment of the nature, betterment of the climate. So it's a challenge for the company to invest and a challenge for the people working or investigating to give the good product. It's really a challenge for all the cases. So, but what is the purpose? If you look at, I'm talking about the chemical industry. So what is that? That is to reduce the emissions, increase recycled inputs to minimize the waste, and develop inherently safer chemicals. So such decisions when the company is taking, the scientists are taking, the people in the research department are taking, these things comes challenge what to keep them. And especially when it is a brand, they always take it more seriously. See, if you look at, you just have a little exposure to shoe companies now. Just have a look. Look at the Puma, what they are producing, Adidas, what they are producing, what sort of sole they are providing for their shoes. Have you ever seen it? Look, the matter has been changed. The material has been changed. All these are R&D products that comes in which are sustainable for this environment. And the same thing is coming later on, followed or copied by other companies. But they may go for, but they may not go for no compulsion for this. But for the brand companies, it is always important to have something which is betterment for the country, for the generation, for the environment, everything. So if you look at a country like USA and you check in a recent Deloitte analysis, around 60 to 65% of companies, and most of them are called as a brand, they agree to the government decisions to maintain their product as a sustainable product. So what happens when you are a brand, you are taking this decision immediately and you are going in the process. But if there are not many companies, they never come as a brand. But they are producing, like if you look at many of the companies that are existing in China, they never call themselves as a brand. They never feel to realize the people that they are a brand. But they are supplying 50 to 60% requirement of the world producing something. So for such companies, it is not a mandatory, so there exists the challenge. So when I am talking about the two companies, one is an example, one is a chemical company, how the company thinks about making a sustainable product to make this world beautiful. And think parallelly, also I will discuss a company like many of you know the IT companies. You must be thinking, what IT company is doing for the sustainability? But it happens. In IT companies also, the companies thinks about the sustainability of the company, for the people, for the future product or innovation that what they are creating are sustainable or not. They are also thinking about that. So I am not coming to all into in detail, but when this comes, this sustainability that comes, what are the emissions you are getting out of your company? See, I'll tell you one thing. It is not only a chemical industry that is giving you the emission. It is every company, every organization is giving emission to this world. Like look at this institute. You must be thinking you are not giving any smoke to this world and spoiling the environment. Leaving about your the vehicles that you are running, look at the light that you are having on your day-to-day affairs, the ACs that you have in your day-to-day activities. All these are giving some emissions which is not good for this world. So every company is deciding in their own way how to reduce this carbon emission to this world, and they are thinking about this. So So this is mandatory for all of them. So this emission process is even thought of in 3 stages, like emission scope of emission 1, 2, 3. I'll show you how things are defined in this. If you look at like the vehicles that are traveling, so you are sending some service into the industry. Not even industry, you look at yours even. When you are sending a vehicle, it gives some emission, that is emission scope of 1. Then it comes, you are running the AC and those things, that's emission number 2. And also emission number 3, which comes conclude all these together. So all company may not be contributing to emission 1 or emission 2, may be contributing to both. So they have to think themselves to think of how we can make something which is sustainable, where it can exist for years together, and a little bit of changes in the innovation can give you that opportunity to have a sustainable world. So let's think about the next example of how to have a sustainable organization like IT sector. See, our business set ever more ambitious environmental, social and governance goals are defined clearly. Their sustainability and technology strategies need to become more tightly enhanced. So, how is it that it's not just you decide a product, you bring it to the market, you sell it, you get the profit? That's not the thing that all the companies now. Now, it is your technology, the sustainability, the environment, the people those are working with you, are they aligned together? Otherwise, the company cannot exist in the sense that you cannot fulfill the target of the government or the board. Like you must have seen in many places, young generation is more acquainted and they feel like that everybody must think about the future world. Everybody also talking about it, but what exactly, who will do something for this? It is only government, the countries, they can decide on this. If the government, the country, they are not going to do something, you cannot do anything. So the young generation, they are the people, they are going to be face it for another 20 to 30 years because they are young. If you see, any agitation that is happening in this world is mostly by young people. That is what they want to show it, that we are the generation who is facing this trouble. So this expression comes in to this industry. That one example is your IT industry. There also the companies are thinking what product I am giving, how I am doing it. Like just you see, the cloud itself, the cloud operations that is available in IT itself is a sustainable attempt to have a good future for us. Like suppose one application is kept on cloud and many people are handling and one service is working for that. Is not that good for the nature? Because many servers are not working for them. Now you think of, if the application is not in cloud and it is distributed among all the people who are working on the same application, there are many servers working for that, and it is taking the trouble, it is taking the energy, it is giving back wrong thing, not good thing to the world. So just think of, it is not only industry or the particular material like making and mechanical and civil engineering, that is what is reason for having a green energy, green world ahead. It can be of anything. So similarly, we are discussing here, like in a IT industry, how it is proceeding. So look at these 3 conditions here. The first one, it says using the power of technology to enable and accelerate sustainability efforts across the organization. See, what are the steps a IT company takes to have a sustainable future ahead. So don't think always it is only the industry which is more responsible for pollution of the world. Your organization running around the clock, having electricity and ACs is giving some. Perhaps you people must be knowing, it will be coming very soon to all organizations, institutions and offices together, that every institution, it's a matter of some years, every institution or offices or organization has to give to the government, has to mention the data that what much contribution they have for the better world in the terms of carbon. So, the first point, using the power of technology to enable and accelerate sustainability effort across the organization. protecting people and the planet by making technology itself progressively more sustainable. So if you want, just try to think of, if you have some innovation which asks for some years to exist and later on things are not good for the world, that is not the thing. So for sustainable technology means you adopt one technology which has a contribution for this world for years together. Even that point also you have to think of. The third one is pursuing breakthrough innovation with ecosystem partners to develop radically different and more sustainable ways to doing business in the future. This is interaction between two organizations or business sector, how they are deciding it to have a sustainable future. So if you look at what we are discussing here is that it is sustainability can be maintained at different stages. People sitting in office, how they will work on. People interacting, the organization interacting with the other one, how do they have it? When you have some innovation or productivity or innovation in your product, you must be very sure about what such of innovation you are putting in so that it will be future for this world. So sustainability through technology is termed in 5 terms here in the IT industry. Accelerating net zero transition, moving towards sustainable value chains. Value chains means this is supply chain. People must be studying or in final year university will be studying. How having a system, supply chain system, so that it will have a good carbon bill. Now we'll be thinking how a supply chain can help us to have this. See, if any of you know the supply chain management, this is very, very important, and though we know it very well, but in a country like India, we have not implemented it well. That is why, because of not a proper supply chain management, the product rates are high, the traveling cost of the product is high, and everything goes multiplication, giving you a bigger value for a particular product. But if you look at European and American countries, they have a very systematic supply chain management that helps in bringing down the price of the product. And also, this helps in reducing the carbon emissions from the different vehicles that you are using, transmitting from one place to other. Next comes your promoting sustainable choice of customers. How the customers are enlightened to have a product which is more sustainable, that even matters. More educated people will decide for a sustainable product. Measurement, reporting and performance of the ESGs, that is environment, social goals of the company. Then comes building and sustainable organization. So organization must be built in a manner you would say that this is a sustainable organization which has the rules, principles and develop a policy to make their organization sustainable, for which the whole result for the company will be good for this. So these are the sum of the analysis. I am not going into it. All these files are discussed here very clearly, that how such things happen in a company like IT industry also. Now I will go. So now what I have done, I have discussed these two things here. Two different sort of organization, profit making organization. One is a chemical industry or some industry of a chemical industry. Other one is a IT sector. Both these organizations, how they think about developing some material or some product which is sustainable for this world. Now come to the topics of how this, what exactly is sustainability, and we are talking so many. If you look at, there are so many research, so many discussions, everything happening on sustainability. What exactly is this? See, this is in bicentennial. If you look at, it's just like what you are getting from the mother earth. You utilize it, give it back to the mother earth, and again she will give it back to you. It's a continuous process of nothing develop, don't develop anything which will spoil this earth, and don't use something which will be ultimately terminated one day. So you do something like when you do something in the industry, it must be helpful for the society, for the economy, for the environment. If these three things are balanced, then you get that things are sustainable. It will sustain for a period. So that is what is sustainability we are discussing. There are so many definitions of ways you can explain. The basic knowledge of sustainability lies in this. So now becomes the smart material, coming to the topic of the materials which is related to your mechanical and civil engineering. We will take some examples to understand how the smart, what are the different smart materials and how they are used for sustainability development and is good for the society. So which are the smart materials? I was just discussing in my first talk to you in the introduction. I was saying that the smart materials are some of the materials which respond, they behave like as if they are alive. They are alive. There is a sense with them. The sense may be in any form. They may de-shape themselves. They may respond to your interaction. They may change their color. They may increase the electricity around them. So it may be of anything. So let's discuss some of these which we generally call as smart material, and it comes in all sectors. It comes in civil engineering, it comes in electronics, it comes in biotechnology, it comes everywhere. So think about your own domain and you just imagine how these smart materials helps, how it works, and how that helps in creating a sustainable world. So look at this. Some of the smart material they are changing their temperature. One of them is set memory alloy. Prior electric is because of mechanical strength. If you give any pressure to these items, these materials, they change the temperature. And if you have some mechanical strain, the electrostatic test, magnostatic test, all this electric polarization, change in magnet field, such things happen here. Electrical field and electrical current, electromagnetic, electrochromic and piezoelectric will give you color change and mechanical state. And you think, okay, we know all these are happening, but how it is sustainable? How it gives a sustainable life together? See, if you prepare something like this and they are interactive, instead of having multiple gadgets for a particular job, you can use this smart material to do your job. That is the thing which brings down the carbon emission to a low level. So that is why we use these smart materials for this purpose. Now look at, I don't know whether it's visible or not, but look at these materials, the polymers, the composites, the ceramic, how these functional properties affect them in processing, in temperature, in weight, strength and durability, flexibility, circularity, stability and efficacy, self-firing. All these things helps in what? Helps in healthcare, consumer products, transportation, electronics and aerospace engineering. So just think of such materials which can substitute for many gadgets, can be used to do your purpose, which helps to bring down the carbon emission. So before understanding the smart material and the sustainability, you must understand what exactly is smart material and how that helps in, and what exactly is carbon emission, the carbon footprint, and the carbon points. You must understand to have a better knowledge on it. So these are the explanations of these. Now we come straight to some of these things. See, smart material electronics are related to, are selectively, that is directness, self-actuation, and there is immediately they will respond to some of the, may it be a temperature, may it be a pressure, they will immediately react to that. So these things are used in electronics. Now coming to smart protein-based materials, there are some protein-based material that will work. So I was just reading yesterday how some of the natural products are kept inside the body, which helps in generating something which gives the strengthness to the muscle, strengthness to bones, and the self-creation things which helps in strengthening the muscle and strengthening the bones. So these are the smart protein-based materials. Similarly, smart mechanical materials, many of you students must be knowing it. The piezoelectric materials, set memory materials, then photoactive materials. These things are example of this. And what is the utilization of this? When you prepare synthetic spider webs, synthetic spider web are the webs which helps in the structure which is more stronger than the steel. Just imagine a recycling product if you can prepare which is more stronger than the steel, how beautiful it is. Just think about for steels to produce, how much energy is used for that. For such thing, this is nothing required. So such applications, graphene is example of this. Is one of the products which are used for preparing these rackets, used for preparing your helmet, used for, and that is also so you can prepare it is a transparent one and very solid, so you can use it as a shield also. So such products are under this. This is another example for civil engineering of permeable concrete. So you know in this what happens is a strength, it's a concrete, but it is porous. So if you can have the light waves can move on, but it acts as a drainage. If water goes into it, it can go directly into the earth. So there is no need for drainage system for it. So similarly in civil engineering also, you know that you have the self-compacting, like civil engineering, you must be knowing that when you are putting concrete into the pillar or beam, you are using a vibrator to make it uniform distribution throughout the beam. But for that, what happens? You are using a electricity power to use the vibrator to make it uniform throughout the beam or the pillar. But here in the self-compacting concrete, you know what happens there? There is no need to use external force to make it compact. They themselves will act to use as a compact. So this is what helps them to reduce the carbon emission because you are not using any electricity or any human activity for such type of things. So these are some of the, there are also a video for this to understand, but I am not discussing this as engineering people. So before understanding the smart material and all, please try to understand what exactly is sustainability which is required for the coming generation, for coming year, so that we can have a better world to live in, a better future for the young generation or the young generation coming in or the people coming in for the future. You cannot be selfish enough to use this earth for your own purpose and live it like that, because from generation to generation people will come up and use this earth for their own purpose. Thank you very much. Hope you have got some idea relevant what I have with me and you are concerned.
Thank you so much, Professor Patnaik sir. You really like discussions on smart materials, shaken media alloys that are the materials which are in the course curriculum. And so here we end the session. Now I request our Honorable Principal sir to kindly come on stage and felicitate Dr. Patnaik with a memento. And I request everyone to please stay back. One announcement to all the registered candidates. Please collect your food coupons from the lobby adjacent to this room, and we will be starting our technical session right at 4 o'clock at room numbers 403, 404 and 405. Now ladies and gentlemen, please put your hands together as our Honorable Principal sir, Professor Dr. Patrick Sarkar, is felicitation Dr. Vinodashis Patnaik, Director of Amity University.
Thank you so much, sir. All the registered candidates are requested to collect the food coupons from the lobby outside, just adjacent. And a big round of thanks to all the participants for attending and being such a wonderful audience and giving your patience here. You've learned a lot. So once again, a big round of applause for each one of you, for each one of JICMs and everyone. Thank you so much.